Hi Year 5, it's great to see you again for another week of maths lessons, and this week in maths we're going to be looking at 2D shape. Before we even start the lesson, you might want to stop and you might want to grab some paper and some pens, and you might want to create a glossary of vocabulary for this week, because as we go through our lessons we're going to be using lots and lots of different vocabulary, things like sides and vertex, and as we go through I might jog your memory about what those things are, and you might want to just jot down a little definition and as I say, compile a list or a glossary of the different shape words. Equally, if you want a bit of help with this, because there are a lot of words to remember, you might want to look on Padlet in the resources section, because there are some reminders, some shape reminders available to you. And also there are loads of different websites out there that you can use to recap about shape and look at the properties of shape. So don't be stuck. There are lots and lots of resources out there that can help. If you're having trouble finding the shape resources on Padlet, please email your teacher and through the Year 5 email, and they will get those to you. And if you want any recommendations of websites, there are a few on the Padlet document. Okay, so let's get started with our lesson. So we're going to start with today's lesson by identifying the names and properties of 2D shapes. So starting with a review task, pause the video, have a look at the questions and see how you go. Okay, so let's go through. It says, look at my 2D shape. What can you tell me about the shape? So we might actually want to start by thinking about what we know about 2D. Well, I know 2D stands for two-dimensional, 2 dimensions. And from our work on square numbers and things in the autumn term, 2 dimensions is meaning that it's got a length and a width. We know that there's no depth, so that shape is flat because it's got no depth, like in a swimming pool or you know, a 3D object. I can't pick that shape up, it's flat. So a 2D shape is flat because it only has those 2 dimensions. Okay, does it remind you of any other shapes? Well, looking at this, if I carried on this line and carried on the line at the top, it could look a little bit like it was a rectangle or a square, but because we've got these pieces cut off, it must be a different shape name. So can we find out how many sides it has by running our finger carefully along each one and counting them? You might have counted them a bit like this. So the sides, if I go through them, we've got 1 there, 2, 3, 4, 5, 6. So we know that there are 6 sides. It says, can you count each vertex by touching each one? So a vertex is a corner. Or you might say, how many vertices are there? So that's like saying how many corners are there. So let me count the corners, and I might do that with a colour as well. So if I start here, 1, 2, 3, 4, 5, 6. And I don't count the next one because I already counted that one. So there are 6 vertices. Now we've worked out how many sides and vertices there are, we should be able to say the shape name. So can you remember what a 6-sided, 6 vertices shape is? Well, it's a hexagon. So here is a STEM sentence for you. You might want to use this for other shapes and their properties as you go through the lesson. So I can say this shape is a hexagon because it has exactly 6 straight sides. Or I could change the STEM sentence and say this shape is a hexagon because it has exactly 6 vertices. So you might want to change that in for things like pentagon or octagon. See if you can come up with the STEM sentence for that. Now it's important that we're talking about straight sides for the moment because none of these sides are curved, they are straight. A curved side would look something like this or maybe something like this. And so because this shape has got straight sides, we can call it a polygon. But there are some 2D shapes out there that are made with curved sides. And so we wouldn't call those polygons. They would be 2D shapes, but not polygons. I wonder if you can think about what those would be, which shapes have got curved sides and are still 2D shapes, but not polygons. Think about that. Okay, moving on to the next activity. I want us to recap triangle names. These are names that you should have come across before, but if not, it's good that we're having this opportunity now to look at those. Okay, so look at the triangles, pause the video, have a think about the questions. Okay, so looking at the triangles, what do we notice about them? Well, they're all green, but we want to notice things that are mathematical about them, really. It's good to notice colours sometimes, but we want to think about the properties of them. What is the same about these shapes and what is different? So let me start by looking at what is the same. So I can see that each shape each triangle has 1, 2, 3 straight sides. 1, 2, 3 straight sides. If I carried on, you would count the same. And I can also see that each one has got 1, 2, 3 vertices. 1, 2, 3 vertices. And again, I could label them on here. So what's the same about the shapes? A triangle is a 3-sided shape, isn't it? Or 3 vertices shape, and that's what makes it a triangle. So now let's think about what's different about the triangles. So I hope you spotted some differences. I can see that in some of the triangles there are different sized lengths, and in some of the triangles there are the same size lengths. So looking at this triangle by eye, it looks like this length and this length and this length are all the same sides. But if I look at this triangle here, it looks like these 2 lengths are longer, maybe they're the same, and they're longer than this length here. Now I could also notice things about the angles as well, because I can see that I've got a right angle in this triangle, and we draw the right angle on by drawing a little square in the corner, the vertices. Now other triangles have got different angles, so you might want to think about that. Now we can use our eye, like I've said, to just kind of have a rough idea about which angles and sides are the same, or we can use mathematical tools to actually prove what we think. So if you want to use mathematical tools, you can. At the end of this PDF, you can see that I've given you a paper protractor, and in your pack there is a paper ruler. So if you don't have a protractor or a ruler at home, you will be able to use those things. So I'm just going to stop sharing for a moment, and I'm going to unpin myself, and I'm going to pin my hopefully, yeah, there it is. I'm going to pin so I can demonstrate using those mathematical tools, and hopefully this will continue recording. Okay, so hopefully you can see my hand now, and you can see the different equipment that I've got. Now you have got a paper protractor that looks like this, but as you can see, it's a bit tricky to use if you don't cut out the middle. So a trick for cutting out the middle is fold your protractor in half, cut a little slit, hopefully you can see, cut a little slit, and then open it back up again, and you'll be able to feed your scissors through the slit, and then you'll be able to cut out the middle part without actually cutting your protractor. So I'll try and do this quickly and neatly. Just bear with me. You will be able to take much more time and be able to do it much more neatly than me, I am sure. Okay. There we go. So you'll also see that I've cut out my paper ruler in advance, and I just want to prove something to you, because you might be thinking, oh, but Miss Rosenthal, what if this ruler isn't actually accurate? So if I put my ruler, my actual ruler, directly over the top of my paper ruler, you'll be able to see that the centimetres are exactly the same, and so are the millimetres. It matches up almost perfectly, okay? The numbers are just slightly different. So you'll be able to do accurate measuring with your protractor, your paper protractor, and your paper ruler. Okay, so looking at this triangle in the middle, we were wondering, now, does it actually have equal sides? So I need to measure these. So you are very good at measuring after your perimeter lessons. I would make that possibly 1.8 centimetres. If I carry on and measure on this side, remember you always measure from 0, so put the 0 on one vertex and measure to the other vertex. So I can go from here to here, and that looks like 1.8 as well. And the final vertex is probably going to be the same, but I'll check it anyway. Yes, it is 1.8. So all sides are equal, which makes it an equilateral triangle. Now, this also means that all of the angles inside should be equal, because if we've got equal length sides meeting at a vertex, then we've got equal angles. So I'll use my protractor to check as well. So I'm going to measure this angle here, which is between these two lines. And so I want to put my target of my protractor on that corner as easily as I can. So I know that it's going underneath the protractor. I'll just kind of be as accurate as I can. And then I want to measure along until I find 0, because that means that I haven't actually started measuring my angle yet. I'm going to measure my angle by looking at the space between that mark and where it touches the next side, like that. Hopefully you can kind of see. Okay, so you might want to grab some some Post-it notes or something that you can actually extend that side width, you could even use your paper ruler, because we want to see where it hits. And actually, if it's an equilateral triangle, I can remember from the snowflakes lesson that we did that it should be 60 degrees. So if I read along from 0 up to where that side would cross the protractor, it is 60. I know that it's a bit fuzzy on my screen, but you'd be able to see this yourself. So if this is 60 degrees, then I know that all the others have to be 60 degrees as well, which makes this an equilateral triangle. Now, we were looking at this one, so I'd be able to use my paper ruler, and I'd be able to measure the sides of this one as well. And I can see that those are the same. They're about 2 centimeters. And this one is different. This one is less than 2. It's about 1.2 centimeters. So I know that that has got 2 equal sides and 1 different. So that would be an isosceles triangle. So if you bear with me, I'm just going to go back to the screen so we can talk about this. Okay, so remove my pin and go back. Sorry, again and share the screen. Okay, super. So if I go back to the activity. Okay, so what do you notice? You might want to go in and fill these in now. Equilateral triangle has got 3 equal sides and 3 equal angles, and those angles have to be 60 degrees because all of the angles in the triangle add up to 180 degrees. An isosceles triangle has got 2 equal sides and 2 equal angles, and so one of the sides is different and one of the angles is different. And a scalene triangle is where you've got no equal sides and no equal angles, but still 3 sides and still 3 angles. Have I missed one out? You might want to add a right angle triangle into that one, just to describe that one as well. Okay, so moving on, I want you now to look at these shapes, different shapes, and have a think about what you notice about them, what's the same about the shapes. Could you give all of these shapes the same name, or would you have to call them something different? And can you describe how some of the shapes are different? You might want to use the STEM sentence at the bottom. Pause the video now and have a go at that. Okay, so this time I hope you've noticed that all of these shapes have got 5 sides, but they don't all have 5 equal sides, and they don't all have 5 equal angles either. So if I think about just proving this, I can just go through now and I can count the sides. 1, 2, 3, 4, 5, and there are 5 vertices. 1, 2, 3, 4, 5. And if I count one of these more irregular ones, let's look at this one. I've got 1, 2, 3, 4, 5 sides, and 1, 2, 3, 4, 5 vertices. So these shapes are all pentagons because they have exactly 5 straight sides. There are no curved sides. But what's different about these shapes? Well, I said it before, but some of these shapes have got different sized sides, and this shape has got all the same sized sides. So as we move on this week, we're going to talk about regular and irregular shapes, or regular and irregular polygons. And if you want to use that vocabulary now, if you already know about regular and irregular polygons, you can apply that knowledge in this lesson as well. Please go ahead and describe them like that. But just so we're all clear, because this has got 5 equal sides and the angles are equal as well, we would call this a regular pentagon. So I'll put an R on that one. But looking at these other ones, I've got all different sized lengths, haven't I? So these are all examples of irregular pentagons. Okay. Now I want you to pause the video and have a little look at these shapes. And again, what do you notice? What's the same about them? Can you give the shapes the same name? Can you describe how some of them are different? Pause the video now. Okay, so I was trying to trick you with this one. I hope you noticed that actually in these shapes, we've got shapes that have got different numbers of sides. So we wouldn't be able to give all of these the same name. A lot of them are hexagons again, because we've got 6 sides. So if I just count, I can prove it here. 1, 2, 3, 4, 5, 6 equal sides, and 1, 2, 3, 4, 5, 6 vertices. So shape A is a hexagon. I can also see that shape B is a hexagon, and not shape C, not shape D. Shape E is a hexagon. Shape F, shape G, shape H. I could check it by counting each side. I'm sure you have, and shape I as well. So this one is slightly different because I've got sides that are all the same length, it looks like, and so the angles would all be the same length as well. So this one would be a regular hexagon, whereas the other ones would be irregular because they've got different length sides. Now let's look at C and D. I'll change my colour because C and D are different altogether. So let's look at how many sides C has. It's 1, 2, 3, 4 sides. So that C would be a quadrilateral because a quadrilateral is a 4-sided shape. And now let's look at D. It looks like it's got more than 4. So if I count this line, 1, 2, 3, 4, 5. So 5 vertices as well. So this would be another pentagon. Okay, so it's important that you do take the time to count the different shapes, count the different sides, count the different vertices, and think about whether they're the same length or whether they're different. Okay, moving on, it's time for us to start thinking about some activities. So as part of the guided practice, I want to start by playing a Guess My Shape game. So we can describe the properties of the shape. So if I pick one, I'm not going to tell you which one it is. I'm going to think about the properties for a moment. Okay, I might want to use some of these ideas to help me. Okay, so let me get started and you can see if you can guess my shape. So it has got 5 vertices. It has got 5 sides. I'm not going to tell you if they're equal or not equal. It has got 5 angles, but I'm going to go a bit deeper with that. I'm going to tell you that it actually has got 2 right angles. So if I just draw a little right angle there, 90 degrees, it's got 2 right angles. So can you guess my shape? 5 vertices, 5 sides, 5 angles, but 2 of them are right angles. So can you fill it in? It must be shape D, which is a pentagon. We could even call it an irregular pentagon. Okay, can you come up with some of your own guess my shape statements? Could you play this game with somebody in your house now? It would be a good one to play with a younger or an older brother or sister. Okay, now moving on to the next task, I want you to think about how you might sort these shapes. So pause the video now. You might want to use a table or a diagram, or you just might want to talk about it. Okay, so what I've done here is I've actually started creating a sorting diagram for you, because sorting diagrams can be a really good way of sorting shapes. But they can take a little bit of time to get your head around, but it's a really good skill to be able to create a sorting diagram because it really shows that you are being curious and inquisitive and choosing the right properties of a shape to sort them. So looking at the different shapes, I've got 5 shapes that I want to sort. So I want to start by thinking about, well, is there a way that I can think about what's similar between them? Can I try and split them into 2 groups? So looking at those shapes, I can definitely see that some of them are polygons because some of them are closed shapes with straight sides. But I can see that this one here is on its own. It's got curved. It's got a curved side, hasn't it? Just one curved side. There are no vertices. So I wouldn't be able to call this a polygon. I'd have to call this just a 2D shape. It's actually a circle, isn't it? Okay, so let me think about this. I can also see that on most of my shapes, more of them have got an even number of vertices than an odd number, because if we just go back through, I know that shape B is a hexagon, so that's 6 sides and 6 vertices. I know that shape H was a hexagon as well, so I'll label that one as 6. I know that shape C was a quadrilateral with 4 sides and 4 vertices. D had 5 sides and 5 vertices, so that's an odd number. So I'm already separating 3 of them from one of them. And K is an interesting one because it's got no vertices and it's only got one side because it's a continual curved side. So that's an odd number as well. So I might choose as my first statement that's going to help me separate them into 2 groups, I might choose something about even numbers of sides or vertices. So here's something I prepared earlier. So I might say it has an even number of vertices. So I'd need to look now and think, well, which shapes can I say yes to that statement about? And which shapes can I say no to that statement about? And I can start to think about separating them. I might want to make some notes on the bottom. So it has an even number of vertices. Yes, that would be shape B, shape C, shape H. And the ones that have an odd number, the ones that I would answer no to that statement about, that would be D and K. But now I've only separated them into 2 groups, I want to see if I can further separate them. So I know I've got B, C and H on this side. Okay, so I might think about what's the difference now between B, C, and H. So I might take a pencil and I might circle B and C and H, just so I can look really closely at what's the same and what's different about them. I can see that B and H have got 6 sides, 6 vertices, so they're hexagons, and C is a quadrilateral. So I might use a statement like this: it's a quadrilateral for my next one. And then I think, which ones can I answer yes and which ones can I answer no? So it's a quadrilateral yes, that would be C. And which ones are a quadrilateral no for H and B? So then I might want to go on and see if I could come up with another statement that would try and help me separate H and B. That would be an interesting one. Okay, on this side, I need to go back and carry on this side. So I know that D and K have an odd number of vertices. And so now I need to think about a statement that would help me separate them out. So I can see that one of these is a polygon and one of them is not. So I might use that statement next. Is it a polygon? So if I answer yes, it is a polygon, that would be D because it's got those straight sides. And if it's not a polygon, it must be K because it's only got one curved side. So hopefully you can see how that works. Now, I just want to show you that actually it doesn't matter really what you put at the top. It doesn't have to be that statement. I said that I wanted to use odd and even to help me separate them. So I could start, rather than talking about even number of vertices, I could say it has an odd number of sides. And that, of course, will change the information that I have below. So if I have it has an odd number of sides, let me just put those back. So I knew that D had 5 sides and K had 1 side. So now D and K would be on this side, wouldn't they? Whereas they were on the other side before. So I'd still need to have a question here that would help me separate D and K. So I might say it has a curved side. And so which one has a curved side? It's K. So K is yes in this one, and D is no. So hopefully you can see how the information that you choose depends on how the shapes get sorted at the end. Hopefully that makes sense. I hope you can have some fun and have some creative thinking coming up with your own sorting diagram, because in your next task, the independent practice, first thing is to identify the shapes in the picture. So you might need to think about, whether they're quadrilaterals or triangles, but really think about what types of quadrilaterals and triangles they are. Push yourself to extend your shape knowledge. You might want to play Guess My Shape with somebody, or if there's no one to play with, please write your own Guess My Shape statements like I demonstrated before. And I'd like you to create a sorting diagram to separate those shapes out. So have a look, first of all, at what would help you put those shapes into 2 equal groups. Okay, question 2 is another way of sorting shapes. So you might use a diagram like this, a table. So you're good at using tables. We did tables earlier this term, didn't we? So it says draw at least one shape in each section of the diagram. So if I'm looking at the criteria here, I know that in this box here, this column talks about at least one right angle, and this row talks about 4-sided. So I need a shape in here that is 4-sided and has at least one right angle. So I could choose a square, couldn't I, for that one? A square has got 4 right angles, so that's at least one, and a square is a quadrilateral, it's 4-sided. But I know that there are other quadrilaterals that would also fit in that box. So I'm going to leave some space and I could draw some other shapes in there. Question 3 of your independent practice is thinking about drawing shapes, but you've got to think about drawing them accurately. So you're given some vertices of some shapes, and it does talk about which type of shape. So have a think about regular and irregular as well, and see if you can draw the vertices that are missing and then draw the sides to join up the vertices to actually create the shape. And then you've got a nice activity here, which is looking at a picture and seeing which shapes you can see, where you can see them, and which shapes are missing, because there are some missing. I had a little look. And it says you can use the table at the end of the document. So I created a table for you that has got all the different types of triangles and quadrilaterals and then the greater shapes. So you can tick if you see it, and maybe you can create a tally for the number of times that you see it, and you can think about where you see it as well in that picture. You could draw your own picture as well, because you might want to see if you can create a picture that has got all of these shapes in. It doesn't have to be, a scene. It could just be an abstract picture with shapes in. There's a deeper thinking challenge, and the deeper thinking answers are on these slides as well, so don't rush ahead. And because the main focus today is to be able to recognize all of the different shape names, which are listed on the table at the end, I would hope that you could recognize every single one of those and describe the properties. Here are some extra activities that will help you practice spotting them, because there is a lot of language here and you are expected in year 5 to be able to spot and know all these different shapes. It will help you as you go up to year 6 and high school. So you might want to go around the house and identify the different shapes that you can see, and you can use another version of that table or your own way of ticking them off. It'd be interesting to think about which shape you found the most of and which shape you found the least of, and think about why that might be. Also, you could create some shape flashcards for yourself, or maybe even for someone younger than you. You could do this with a brother or sister, like I said before, especially the trickier shapes like parallelograms, rhombuses, isosceles triangles. Push yourselves, guys. If you know a square, maybe don't create a sign for or a card for a square. Maybe focus on those ones that are tricky. You could challenge yourself to choose a card and name the shape and see if you can describe 2 properties of that shape in less than 30 seconds, or give yourself some other time limits. And you can investigate, here's an investigation, whether there is such a shape as a diamond or whether it's actually a rhombus. So you might like to use this website to help you. So that link is on Padlet as well. So I hope you have some fun with these shape activities, and I hope that it prepares you well for the next shape lessons. We're going to be looking at different types of lines tomorrow, really focusing in on quadrilaterals. And then on Wednesday, we're going to be looking at angles. And on Thursday, we're going to really focus in on regular and irregular shapes. So it will be great to see what you come up with. Send your work into the Year 5 email, especially if you come up with pictures. Let us know what different types of shapes you found and which shapes you didn't find, all that kind of stuff. Okay, thank you, and I'll see you tomorrow, guys. Bye.